Hello everyone, welcome back to our channel Adi Begin Engineering. Today we will learn about indeterminate forms and El-Hospital rule. See, we know that limit x tends to a f of x by g of x can be written as limit x tends to a f of a by limit x tends to a g of x. If we put the limit here, then it will be f of a. Or let us take it as f of x, provided that g of x should not be 0. If g of x is 0 and limit x tends to a f of x is not 0, then this limit cannot tend to a finite value. Okay, so a fraction with both numerator and denominator tending to 0 as x tends to a assumes the indeterminate form 0 by 0. Okay, so if this function is of the form 0 by 0 when x is tends to a, then we call this limit as indeterminate form. There are other indeterminate form also. So one we have learned 0 by 0. Others can be infinity by infinity is also indeterminate form. Infinity minus infinity is also indeterminate form. 0 multiplied by infinity is also indeterminate form. 0 to the power 0, 1 to the power infinity, and infinity to the power 0. These are all indeterminate form. Okay, so if you notice, there are 7 indeterminate forms. So how to evaluate when we encounter this type of indeterminate forms? Here comes the El-Hospital rule. El-Hospital rule, or we can say El-Hospital theorem also. Now see, the statement is, if two functions f and g are continuous in the closed interval a comma b, derivable in the open interval a comma b, and number 3 is limit x tends to a plus f of x is 0, that is equals to limit x tends to a plus g of x. Then we can say limit x tends to a plus f of x by g of x is equal to limit x tends to a plus f dash x by g dash x. So this is the statement of El-Hospital rule, that is, these functions f and g should be continuous in the closed interval a comma b, should be derivable in the open interval a comma b, and if both the functions are limiting value of the functions are 0, then we can write this function as f dash x by g dash x, that is, we have to do the first derivative. If you see that after doing first derivative, it again comes to be 0 by 0. Okay, then you have to do the second derivative. Okay, then you have to do the second derivative, and it goes on. If you find that again it comes out to be 0 by 0, then you have to do the triple derivative until and unless this 0 by 0 forms omitted. Let us see one question regarding this. We have to evaluate limit x tends to 0 to sin x minus sin 2x by x cube. If you look closely here, sin 0 is 0, sin 2x, that is sin 0 is 0, and this is 0. So 0 by 0 forms. So that means we have to apply L'Hospital rule. So what is the rule? Derivative of the numerator separately and derivative of the denominator separately. So limit x tends to 0 to derivative of sin x is cos x, derivative of sin 2x is cos 2x, and when it enters 2 will come out and dx by dx is 1. Derivative of x cube is 3x square. Now if you put 0 again, this will be 2, this will be 2 by 2 minus 2 is 0, 0 by 0. So again it is 0 by 0 form. That means we have to derive this thing again. That is derivative of numerator again and derivative of denominator again. So it will be limit x tends to 0 twice differentiation of cos x is minus sin x, 2 differentiation of cos 2x is minus sin 2x, so it will be plus, and 2 will come outside, so it will be 4. Dx by dx is 1, and it will be 6x, derivative of 3x square. If we put 0, again it is 0 by 0 form, so you have to differentiate it again. So it will be limit x tends to 0 minus 2 cos x plus 8 cos 2x, sin 2x derivative will cos 2x, and when it enters 2 will come outside, so 4 into 2 is 8 by 6. Now you can put the value 0, cos 0 is 1, cos 0 is 1, so 8 minus 2 is 6, 6 by 6 is 1. So our answer to the limit is 1. Now if we talk about our next indeterminate form, let us say we are talking about infinity by infinity form. Okay, so here theorem regarding infinity by infinity is if limit if limit x tends to a, f of x is infinity, limit x tends to a, g of x is infinity, and if limit x tends to a, f dash x by g dash x is, let us say, L, then limit x tends to a, fx by gx will also be equals to L. Let us see one example regarding this. See, we have to evaluate limit x tends to infinity, x square by e to the power x. If you put infinity, it will be infinity, e to the power infinity is infinity. So this is in the form infinity by infinity. So what you have to do? First, differentiate numerator and denominator separately. So it will be limit x tends to infinity. This will be 2x by e to the power x. Differentiation of e to the power x, e to the power x, and x square is 2x. Now if you put infinity here, again it will be infinity by infinity form. So again we have to differentiate. So limit x tends to infinity. This is 2 by e to the power x. Now if you put x tends to infinity, e to the power infinity is infinity, 1 by infinity is 0. So answer is 0. Okay. Now if we talk about our next form, that is 0 multiplied by infinity form. So let limit x tends to a, f of x is 0, and limit x tends to a, g of x is infinity. Then limit x tends to a, f of x multiplied by g of x. See, f of x is 0 and g of x is infinity. So this is 0 into infinity form. Now this limit can be written as limit x tends to a, f of x by g of x. You can write it as 1 by g of x. Now g of x is infinity, 1 by infinity is 0, fx is 0. So now this is in the form 0 by 0. Okay. Or you can write it as limit x tends to a, g of x. You can write f of x as 1 by f of x. So g of x is infinity, f of x is 0, 1 by 0 is infinity. Now this is in the form infinity by infinity. So you can differentiate numerator and denominator separately. So remember, except infinity by infinity and 0 by 0 form, other forms you have to write it, or you have to arrange the forms in either 0 by 0 form or in infinity by infinity form. Let us see one example so that it will be clear more. Limit x tends to 0 plus x to the power n log of x. Here n is positive. Now if you put 0, x to the power 0 is, this is x tends to 0 plus. So 0 to the power n is 0. Log of 0 is infinite. So this is 0 into infinity form. So we have to arrange it either in the form 0 by 0 or in the form infinity by infinity. So let us say limit x tends to 0 plus. We can write log of x, and we can write x to the power n is 1 by x to the power n. So it will be, see, 1 by 0 is infinite, log of 0 is infinite. Now this form is infinity by infinity form. Okay. Now we can write it as limit x tends to 0 plus log of x by x to the power minus n. If you differentiate numerator and denominator, so it will be limit x tends to 0 plus Differentiation of log x is 1 by x. Differentiation of x to the power minus n is n into x to the power n minus 1. So minus n into x to the power minus n minus 1. If you put 0, it will be 1 by 0 infinite, and if you put 0 here, so it is actually 1 by x to the power n plus 1. So 1 by 0 is infinite. So again it is infinite by infinite form. If you take minus 1 by n outside, so it is limit x tends to 0, and if we simplify, this is x to the power minus 1, and this will be x to the power minus n plus 1. So x to the power minus n plus 1 will x to the power plus n plus 1. So plus 1 and minus 1 will cancel out, and you will remain with x to the power n. So if you put 0, 0 multiplied by 1 by n is 0. So answer is 0. Now let us see our next form, which is infinity minus infinity. Let us see this form. Now let limit x tends to a f of x equals to limit x tends to a g of x is infinity. Now if our function is this limit x tends to a f of x minus g of x, so it is infinity, and this is also infinity. So this is in the form infinity minus infinity. Now we can write this function as limit x tends to a you can write this function as 1 by f of x minus 1 by g of x divided by 1 by f of x into g of x. If you take LCM, it will be, you have to take this as g of x and this as f of x. Now if you take LCM, this will be g of x into f of x, and in the numerator you will get f of x minus g of x. So this g of x, f of x will cancel out with this, and you will remain with this function. Now our limit x tends to f of x and g of x are infinity. So 1 by infinity is 0, 1 by infinity is 0. So this is 0, and 1 by infinity is 0. So 0 by 0 form. So now our function reduces to 0 by 0 form. Now you can apply L'Hospital rule here. So let us see one example. We have to evaluate limit x tends to 0, 1 by x into 1 by x into this is minus 1 by e to the power x minus 1. Now if you see 1 by 0 is infinity and x is 0, e to the power x minus 1. So e to the power 0 is 1, 1 minus 1 is 0, 1 by 0 is infinity. So this is in the form infinity minus infinity. So you have to arrange this function as 0 by 0. So let us take LCM first. So it will be x into e to the power x minus 1, and it will be e to the power x minus 1 minus x. Now if you put 0, e to the power 0 is 1, 1 minus 1 is 0, this is 0, and this is 0. So it is in the form 0 by 0. Now take the differentiation in the numerator and denominator separately. So you will get limit x tends to 0. Differentiation of e to the power x is e to the power x. Differentiation of 1 is 0 and differentiation of x is 1. And if you take u into v rule, so if we take e to the power x minus 1, then differentiation of x is 1, plus if you take x, then differentiation of e to the power x is e to the power x, differentiation of 1 is 0. So we put 0 here, it is 1 minus 1 0, 0 here, it will be 0, and 1 minus 1 is 0, because e to the power 0 is 1. So again it is in the form 0 by 0. Again you have to differentiate. So limit x tends to 0, e to the power x is e to the power x, y e to the power x is e to the power x, differentiation of 1 is 0. Again you have to apply u into v rule. It is keeping x, differentiation of e to the power x is e to the power x, plus keeping e to the power x, differentiation of x is 1. Now if you put 0, e to the power 0 is 1, this is 1, this is 0, this is 1. So 1 plus 1 is 2. So half is the answer. Now if we have the other three forms, that is 0 to the power 0, 1 to the power plus minus infinity, and infinity to the power 0. So for these three forms, you have to assume let y is equals to limit x tends to a, f of x to the power g of x, and then take log in both the sides. Okay, take log on both the sides. If you take log on both the sides, it will be log of y equals to, we know the property log of x to the power y, y will come outside, so it will be y log of x. So here f of x, g of x will come outside, limit x tends to a is there, into log of f of x. Now if you put a, it will take the form 0 into infinity. Now we have discussed how to reduce this. We have to apply the same methods. So remember this, in this type of questions, you have to take log on both the sides, and the form will reduce to 0 into infinity form, and we have discussed our 0 into infinity form. Apply that method. So let us see one question. We have to evaluate limit x tends to 0 sin x by x to the power 1 by x. If you put 0, limit x tends to 0 sin x by x is 1. We know the property of limits. And 1 by 0 is infinity. So this is in the form 1 to the power infinity. This is fx to the power gx form. That means we have to take log on both the sides, and we have to assume y equals to this function. So let y equals to limit x tends to 0 sin of x by x to the power 1 by x. Now take log on the both sides. So log of y would be limit x tends to 0, 1 by x will come outside, log of sine of x by x. Now if you apply limit, actually you have to apply limit on both the sides, so it will be limit x tends to 0. Now see this form, you can write it as limit x tends to 0 log of y. If you first assume that function is y equals to this, then take log on both the sides and take limit both the sides, so it is now more understandable. So limit x tends to 0 log of y, you can write it as limit x tends to 0 log of sine of x by x by x. Now if you put 0, then limit will go inside, and limit x tends to 0 sin x by x is 1, log of 1 is 0, and here x is 0, so it is in the form 0 by 0. Now take differentiation in the numerator and denominator, so it will be limit x tends to 0 log of x, differentiation of log of x is 1 by x, so it will be 1 by sine of x by x into, now you have to apply u by v rule for sin x by x, so it will be v square, keeping v, differentiation of sin x, that is cos x, minus keeping sin x, differentiation of x is 1, whole divided by differentiation of x is 1. Now this is limit x tends to 0 x cos of x minus sin of x by 1x will cancel out from here, it will be x sin of x. We put 0, this is 0, sin 0 is 0, this is 0, so again it is 0 by 0 form. We have to take the differentiation again. So limit x tends to 0, here you have to apply u and v rule, so keeping x, differentiation of cos x is minus sin x, plus keeping cos x, differentiation of x is 1, differentiation of sin x is cosine of x. You have to take the u v rule, you have to apply u v rule in the denominator also, so keeping sin x, differentiation of x is 1, keeping x, differentiation of sin x is cosine of x. Now we put 0, this will be 0, cos 0 is 1, this is 1, this is cancels out actually, so 0 by sin 0 is 0, this is 0. So this is again 0 by 0 form. Now apply L'Hospital again, so limit x tends to 0, this you have to apply u into v rule again, so keeping minus sin x, differentiation of x is 1, plus keeping x, differentiation of minus sin x is minus cos x, divided by sin x, differentiation is cos x, you have to apply u v rule here, so keeping x, differentiation of cos x is minus sin x, and keeping cos x, differentiation of x is 1. Now if you put 0, sin 0 is 0, this is 0, cos 0 is 1, this is 0, cos 0 is 1, so this is 0 by 2, that means 0. Okay, and the left hand side we have limit x tends to 0 log of y, is 0. So we can say that log of limit x tends to 0 y is 0. So this is e base. So that means limit x tends to 0 y is e to the power 0. E to the power 0 is 1. So it will be 1. So our answer is 1. Okay. Now let us see another question regarding this. We have to evaluate the limit x tends to 1, x by x minus 1 minus 1 by log of x. So if you put x tends to 1, it will be 1 by 0, that is infinity, and log of 1 is 0, infinity. So this is in the form infinity minus infinity. So first of all, we have to make this in the form 0 by 0 or infinity by infinity. So limit x tends to 1. If we take LCM, then it will be x minus 1 into log of x, and this is log of x, x log of x minus x minus 1. So if you put 1, log of 1 is 0, 1 minus 1 is 0, 1 minus 0. So this is now in the form 0 by 0 form. So you can apply the hospital here. So limit x tends to 1. This is u into v rule. Keeping log x, differentiation of x is 1. Keeping x, differentiation of log x is 1 by x. Minus differentiation of x is 1. Differentiation of 1 is 0. You have to apply u into v rule. Keeping x minus 1. Differentiation of log x is 1 by x. Keeping log x, differentiation of x is 1. Now if you put, this is x will cancel out, 1 will cancel out, 1 minus 1 is 0. So this is log of x by, if you multiply this, you will get 1 minus 1 by x plus log of x. Now 1, if you put 1, 1 minus 1 0, log of 1 is 0, log of 1 is 0. So this is again 0 by 0 form. So you have to take the differentiation again. So limit x tends to 1. Differentiation of log x is 1 by x. Differentiation of 1 is 0. Differentiation of minus 1 by x. So minus 1 by x, you can write it as minus x to the power minus 1. So this is x to the power n form. It will be n into x to the power n minus 1. So this will be plus 1 by x square. Differentiation of log x is 1 by x. If you put 1, it will be 1 by 1 plus 1, that is 2, half. So half is the answer of this question. Now let us see another question. Show that limit x tends to pi by 2, sine of x to the power tan of x is 1. So if you put pi by 2, sine pi by 2 is 1, tan pi by 2 is infinity. So this function is 1 to the power infinity form. So remember the process we have discussed. We have to take y as sin x to the power 10x. Then take logarithm on both the sides. Then it will be log of y equals to tan of x into log of sin x. Then take limit on both the sides. So it will be limit x tends to pi by 2 log of y is limit x tends to pi by 2 tan of x into log of sin x. Now if you see, you can write it as limit x tends to pi by 2 log of sin x by tan x. You can write it as 1 by cot x. So if you put pi by 2, sin pi by 2 is 1, log of 1 is 0, cot pi by 2 is infinity, so tan pi by 2 would be 0. So this would be 0 by 0 form. Now you have to take differentiation. So limit x tends to pi by 2, log of x is 1 by x, so 1 by sin x. Differentiation of sin x is cos x, and differentiation of cot x is minus cos x square x. Now if you simplify, it will be sin square x will be in the numerator, 1 sin x will cancel out, it will be minus sin x cos x. So limit x tends to pi by 2 minus sin x into cos sin x. If we put pi by 2, sin pi by 2 is 1, cos pi by 2 is 0, so answer is 0. This is 0, and in the left hand side we have limit x tends to pi by 2 log of y equals to 0. So we can write it as log of limit x tends to pi by 2 y, that is 0, this is e base. So limit x tends to pi by 2 y b to the power 0, that is 1. So 1 is the answer. Okay. So all the problems here are in the same format. What you have to do is to arrange them in the proper format. Then there is nothing but taking the differentiation. Okay. Now let us see our next question. Find the values of a and b such that limit theta tends to 0, theta multiplied by 1 plus a cos theta minus b sin theta upon theta cube equals to 1. Okay. Now see, let's see the solution. Limit theta tends to 0, theta multiplied with 1 plus a cos theta minus b sin theta upon theta cube. If you put theta 0, this will be 0 minus 0 and 0. So this is 0 by 0 form, right? So take the differentiation in the numerator and denominator separately. So it will be limit theta tends to 0. So apply u into b rule. Differentiation of theta with respect to theta would be 1, putting 1 plus a cos theta as it is. Now keeping theta, differentiation of 1 is 0, differentiation of cos theta is minus sin theta, so it would be minus a sin theta. Minus sin theta differentiation is cos theta divided by 3 theta square. Now see, here denominator is 0, right? If theta is 0, denominator is 0. Now, if this limit has to be a finite value, then numerator should be 0. for theta equals to 0, right? Only then we can apply L'Hospital rule. So we can say if theta is 0, numerator should be 0. That means 1 plus a into cos 0 is 1, so 1 plus a. This whole thing is 0. Theta 0 multiplied by something 0. This is cos 0 is 1, so plus b. Okay, sorry, here is minus sign, so it would be minus b. That should be 0. So from this we can say b equals to a plus 1. Okay, so in that case our equation would be limit theta tends to 0. This is 1 plus a cos theta minus a theta sin theta, and this b can be written as a plus 1. This is a plus 1 cos theta divided by 3 theta square. Now if you simplify, this will be limit theta tends to 0, which is a cos theta, and minus a cos theta will cancel out. So you will get 1 minus, from this you will get minus cos theta, so 1 minus cos theta, and this is minus a theta sin theta upon 3 theta square. We put theta 0, it will be 1 minus 1 0, this is 0, this is 0, so again 0 by 0 form. So this will be limit theta tends to 0, differentiation of 1 is 0, differentiation of cosine of theta is minus sin theta, so it will be plus sin theta, minus minus plus, it will be minus a, and you have to apply u into b rule. So if you keep sin theta, differentiation of theta is 1, there will be plus, and outside there is minus, so it will be minus. And if you keep a theta, differentiation of sin theta is cosine of theta divided by 6 theta. If you put theta 0, it will be 0, this will be 0, this will be 0, again it is 0 by 0 form. So now apply L'Hospital again, limit theta tends to 0, sin theta differentiation is cosine of theta, this will be minus a cosine of theta, again apply u into b rule, so keep a outside, keeping theta, cosine of theta will be minus sin theta, plus keeping cosine of theta, differentiation of theta will be 1 divided by 6. Now if you put theta 0, this term will be 0, this whole term would be 0, this term would be 1, this term would be a, and from this cos 0 1 you will get minus a, so minus a minus a minus 2a, so you will get 1 minus 2a upon 6, and it is given that this limit is equals to 1. So this is equals to 1. So from this a would be minus 5 by 2. So if a is 5 by 2, we know the relation b is a plus 1. B is a plus 1. So minus 5 by 2 plus 1. So this will be minus 3 by 2. So we got the value of a, that is minus 5 by 2, and we got the value of b, that is minus 3 by 2. So that's all for today. I think you have understood this chapter. Now practice 8 to 10 questions on your own, and this chapter will be done. So I think you have liked it. Please share with your friends. Comment on the section if any video requests or which chapter you need me to upload. Kindly comment, like, share and subscribe. That's all for today. Thank you and have a good day.